Okay, the last standard for your trig units is standard P2. And we're going to talk about the other properties or some other properties that happen with trig equations called composite argument. Composite, that word, if you've heard it before, usually means that you're combining two. Now, composite argument, what that means is in the argument of a sine or the argument of a cosine, you're going to end up having two different things in your argument that you're combining together somehow. And the reason we talk about these properties is because this does come up, and we have to be able to at least recognize these properties so that we can use them to simplify a problem to solve it. So much like we were doing yesterday with taking linear combinations of two linear trig functions, and then combining them into one cosine with phase displacement, using that property to rewrite it so we can solve it. This is kind of the same idea. You're going to be having different properties here that we're going to list, where when those properties are in play, it helps us solve problems algebraically. Now, there's usually like a whole big spiel that I take to show you where the properties come from and how they work. We're not going to take the time to do that here because that's not what I need you to do with them. If this was just a trig class, I'd probably make you go through the whole shebang. But my goal is to get to the calculus stuff so that we can practice that a whole bunch and spend a lot of time talking about that. Alright, let's start with making our list. We're going to start with cosine of a minus b. Now, cosine of a minus b, this is different because actually both of these are going to represent angles here. But composite argument, so two things, you're either adding or subtracting. Cosine of a minus b, this is the main one because, and this is the one, like if I was going to go through and prove everything, we would prove that one, show where it came from, because then all the other ones are built off of this one. So that's why that one's first. Okay, the composite argument property says if you have cosine and you have two things and you're subtracting those two things in the argument, then the cosine doesn't distribute. Like this does not become cosine A minus cosine B. Cosine is a function of this argument. It doesn't distribute. This is attached to this cosine. But we can make this look different using a property. And the property is that cosine A times cosine B plus sine A sine B. So whatever the value of this is would be the same as the value for this. Then we have cosine of A plus B, because you could add two things in the argument. You'll notice it's the exact same property. You're just subtracting. Okay, so there's cosine. The next group we're going to talk about is sine. So, sine of A minus B. If you have a composite argument for sine, you can make that look different using the property. Property is sine A cosine B minus cosine A sine B. And then sine of A plus B is the same, except the sign changes. Okay. And then the last two that we're going to talk about is tangent. So if you're subtracting the composite argument, it becomes this fraction tan A minus tan B all over 1 plus tan A times tan B, and then tan of A plus B. Same thing, you just add on the top and subtract on the bottom. Okay, so these are the properties we're going to use. Now when we go to use them in the following examples, you're going to be looking for situations where you can either go this direction or go backwards, because they can go either or. The first one we're going to look at is actually using the property to solve. Well, let's just use the property to rewrite. We'll just practice with one of these. And why don't we practice with sine of a plus b. So we're going to rewrite sine of, let's go with, I don't know, 2x plus 4y. We're going to rewrite that expression using the property. And property meaning composite argument because you're adding two things. Alright, so if we were going to rewrite this using the property, you'd go find the sign where you're adding the two things in the argument, which is this one here. I'm just going to go ahead and rewrite it, the straight property. My suggestion is until you have these memorized, every time you have to use it, rewrite it out without plugging anything in to begin with, because that's going to help solidify it in your brain. And you're going to plug in stuff where they go. Now, in the argument, A represents the first term, B represents the second term. So then, wherever A is, I'm going to put 2x. Wherever B is, I'm going to put 4y. And so that, right there, is the rewritten version of this expression using the property. Okay, now, this example is just practicing using the property. But the point in these properties are what we would use them for when doing example 2 and 3. So for example 2, let's take this expression, sine, we're going to solve sine 5x cosine x, 5x cosine 3x minus cosine 5x sine 3x equals 1/2. Okay, we're going to solve this for values between 0 and 2 pi. We're going to solve this algebraically. Now, in an expression like this is pretty complicated. You have a sine and a cosine. This is not linear combinations because there's two, like you have two things that you're adding or subtracting, and there's no powers. That part's correct. But you have two different functions here and two different functions here. In the problems we were doing yesterday, you just had a single sine and a single cosine, not them grouped together at all. So this becomes a different property. And if we look back, we're looking for the pattern where it's sine, cosine, cosine, sine with a subtraction in between. So look through your list. Here I have sine, cosine, cosine, sine with a subtraction in between. So I can go backwards here. This is the pattern I have. I can then use this and rewrite it to be sine of a minus b. Okay. So again, maybe at the very top here, I'm just going to rewrite the property to get comfortable with it. Okay. And then I'm going to identify what my a and my b are. My a is the first argument inside. My b is the second argument. And you can see that it matches up here. Same thing, a, b. Notice that has to be the same. You can't have two different a's. You can't have two different b's. You should see the repeated argument in both cases. So I'm going to rewrite that section to look like the other side of the property, where you have sine of 5x minus 3x then. And that's equal to 1/2. Well, now that I have it combined into one argument, I can simplify that because they're like terms. So then I get sine of 2x equals 1/2. And if I have to solve this algebraically, I'm now set up to do that. I can take the arc sine of both sides. And then divide both sides by 1/2. And then let's go ahead and write the general solution here. Actually, I have two here. Okay, so there's my general solution. And then I've kind of already done this part here, but if I was to put, or at this point I would put both of these into my calculator and punch out the solutions for 0 to 2 pi. And in the interest of time, I'm not going to do that quite yet. But I think at least getting to that point, you would know what to do from there. Example 3, solving equations. So we're going to do another one here. Okay, so here's another problem where there's no way that I can isolate tangents. Yes, I have one function, I have a tangent, but they both have different arguments, which means I can't isolate one of them. So in order to do this problem, I have to look for a property that will transform that into something that I can use. So I'm looking for the tangent property that has the subtraction sign on the top and the addition sign on the bottom. We'll just make sure that it matches that pattern, tan of A minus tan of B over 1 plus tan A tan B. That's the pattern I have. And it looks like, did I put plus? It looks like it fits, looks like it fits this first tangent property. So again, just to practice here, I'm going to rewrite this tangent property off to the side. Oops. I'm going to identify what my A and my B are, or my two different arguments. Looks like 4x is my A, x is my B. And then this whole thing is going to be transformed by this property and become tan of A minus B. So I have tan of 4x minus x. And again, I can subtract those because they're like terms to get tan of 3x. Then I can take the arctan of both sides, divide by 3, and then write the general solution. And then in order to solve this, I would put that equation into the calculator, and I would give you a range, like from 0 to 2 pi or something like that, and you would solve it the rest of the way by putting it in the calculator. Okay. Okay, now for the type 4. We're going to do one type 4 together, just to give you a introduction to it, and then this last example we'll do in class together tomorrow. So, let's look at this first example. I need you to mark a set of axes here. And notice this says finding exact values. So, we're going to do things with the properties, but not using an equation format necessarily, just using the property and some ratios that we're going to draw here. I want you to draw that right triangle, and then draw another right triangle right there. And then we're going to mark some things about this right triangle. From here to here, it's going to be 7. From here to here, it's going to be 15. That's 8. This is 17. This side is 24. This side is 25. Okay. And then we're going to do two things with these ratios. We're going to find the value for cosine of A minus B, and then we're going to find the value for tangent of A plus B. Okay, and I should say that the angle A is that angle and angle B is that angle. Because A and B, remember, are angles, and we could say that they're angles that form some type of reference triangle, and I'm giving you the reference triangles here. So what we're going to start off with is when you've identified or I've told you what property that I want you to find the value of, we go to our list, and we mark down what cosine of A minus B is. Cosine of A minus B is this property, so I'm going to write out that property. Okay. Now when you're doing these problems, we need to find the individual value of cosine of A, then the individual value of cosine of B, the individual value of sine A and sine B. And when you find the individual values, since you have triangles, you're going to look at them in terms of SOHCAHTOA. So cosine of A, my angle A is in this taller triangle. Cosine is adjacent over hypotenuse. So you look at that bigger triangle there, and the adjacent side is 7, and the hypotenuse is 25. So the value for cosine of A is 7 over 25, because cosine is that ratio, adjacent over hypotenuse. Cosine of B, now we're looking at this triangle. Cosine is still adjacent over hypotenuse, so now that's 15 over 17. Sine of A. Now, this is why we can't use a calculator here, because I don't know what the angle is, but technically I don't care what the angle is, because I have enough information about my triangles, I can come up with the value. So sine of A is opposite over hypotenuse, so we have 24 over 25, and then sine of B is going to be opposite over hypotenuse, or 8 over 17. And then we're going to go ahead and simplify this. So taking a calculator, which of course I put all of mine away. Multiplying across the top, you get 105 over 425. Then we're going to add 192 over 425. Add across the top, you get 297 over 425. And that should be your final answer here. You can't reduce it. It's exact because we don't have to round. And if we did this problem and tried to find A and B, the angles first, and then do it that way, you would get decimals. So exact means no decimals, just use the ratios. Alright, tan of A plus B. Same thing, we go back to the property. We're going to write down this property and then plug in what we know. So that's equal to tan A plus tan B over 1 minus tan A tan B. Okay. The value of tangent of A, you look at angle A. Tangent is opposite over adjacent, so 24 over 7. Tan B is 8 over 15. Opposite over adjacent. Bottom, tan of A was 24 over 7, and tan of B was 8 over 15. Okay, and then we're going to simplify across the top. Now, in order to add those fractions together, I need common denominators. So it's going to be 15 over 15. Let's put this way, 7 over 7. You get 360 over 105 plus 56 over 105. Then down here, you have 1 minus this here. Let's actually multiply those together. So this would become 192. 192 over 105. And if I'm taking 1 and subtracting, you still need common denominators, so this is going to become 105 over 105. 105 minus 192 is negative 87 over 105. And then we're going to add across here, so 360 plus 56 gets me 416 over 105. And on the bottom, I get negative 87 over 105. I'm going to flip that and multiply, and when I flip and multiply, your 105s cancel, just leaving you with 416 over negative 87. And that's your answer there. So, still just practicing using the properties, but finding exact values instead of punching it out on a calculator. And that's it for the notes. We'll do example 5 together tomorrow as a warm-up.